Okay, so the goal here is to talk about some practical aspects of coding rotation. And I know I already gave you one video. I wanted to give you an extra one. Let me hit pause on here. Okay, Jesse's out of here. That's cool. All right, so let me do, let me go to share screen. Sorry, I'm getting tired too. It's been a long day. And let's go to, let me bring this over. Got a number of windows open. Let's go to GlowScript here. This is the code I'm going to try to help you walk through. So rather than just read it, I've got it on a different screen here, and we're going to start from scratch. So let's make a new program. And if you want to code along with me, you can. You do not have to. But again, this will probably help you tomorrow. You've got the video, whatever you think is most fun. So I'm just going to create something called rotation test 2. Now I'm going to create an object, a ball, and let's call that a sphere. And I'm going to give it some properties. Let's say its position is, it's a vector, right? So let's just say it's at -3. Actually, let's say -2, 0, 0. All right. And let me see, what else do I want to do with that? Oh, and I'm going to make this ball, whoops. I'm going to choose to make it 0.25, and I think I'm going to make it a color here. Yeah, let's give it a color. I'm going to choose cyan, 0, 1, 1. And I'm just going to tighten this up. So before I get ahead of myself, I'm going to run this. That's just draw a ball on the screen. So far, so good. Now, I'm going to do an x-axis and a y-axis. And to speed this up, I've got this part. This is kind of boring, so I'm just going to copy this and paste it in here. So all I've done is I've drawn some x-axis and y-axis. And notice one of these is going to be red, and one of them is going to be yellow. Let's run this. So far, so good. We've got a ball at the end of there. Now, I'm going to add in something I want to rotate. And nothing here is too crazy yet. We're just drawing stuff. So now what I want to do is I'm going to create a line. And that line is going to be a cylinder, just like the axis, except this one is colored white. Because I didn't specify a color, we're going to use the default color. So when I run this, it should actually cover up the x-axis. All right, so it's there. And in fact, if I made this radius a little bit smaller, you could see that they're literally right on top of each other. Oh, it's inside of there now. Whatever. But okay, so the white and the red are basically right on top of each other. Now, if we're going to rotate something, like let's say I want to rotate this line. I do not want to rotate the axes. I want to rotate this line. I need to give it some angular acceleration or angular velocity, right? So what I'm going to do, I'm going to create a new attribute called alpha. That's the angular acceleration, right? So do you want that to be a vector or a scalar? What do you think?
That's a scalar, right?
We could use it as a scalar, sure. And so then if I define it as a scalar, I would just type in, let's say, the number 1. Okay, now it turns out you could actually define it as a vector as well. We could show you that change at the end. Either one would have been fine. Now, what's another property that we might want to specify? Not just the angular acceleration, but perhaps we might also want to specify its
velocity.
Omega. So that would be, let's start it with rate 1. 1 as well. Now, I'm assuming because you called the alpha a scalar, I'm going to assume the rotation rate should also be a scalar. So far, so good, everybody? Now, what I want to do now is I want to rotate this thing, so I might need an angle. So let me, I'm just going to show you how angles work in case you've forgotten. Let's say we want to do a 180-degree angle. In degrees, it's 180, but coding, we need to use radians. Does anybody remember the command to change from degrees to radians?
Isn't it just rad with the open parentheses? Oh,
Radians.
Okay.
Yep. And so, very good. How could we check if this is working? What's something I could
Have
do?
it print.
And what should the answer spit out if I'm doing it correctly?
Quick question. Why is the word print important?
Oh, print is the command you use to tell the computer to output something. I'll show you what happens if we don't do it in a minute. Is that okay?
Yeah, like, okay.
Yep. So let me ask you, if I use 180 degrees, what should the radians be?
3.14.
3.14 pi. So let's scroll down. It's looking like it's working. I was just doing that to make, this is a trick I do before I get too far along. I want to make sure the code's working. All right. So now that looks good. Now to show you what happens, Gonzalo, if I take this out by commenting it, the computer still does it, but it doesn't show me. I can't scroll down. Whoops. Ah, that's not what I wanted. I wanted this one. Whoops. So we don't need that right now, or this. Oh my God. Okay. Yeah. So I notice I can't scroll down here. So Gonzalo, does that answer your question? Print is the command you use to tell it to actually output something.
Yeah, that makes sense now.
All right. And now let's do 45 degrees. We know it's working, so I'm going to take out this print command. All right. So that's just commented out. It's still there, but the pound sign means it's commented. So now the trick is I want to rotate that line by 45 degrees. Okay, let's say I want to rotate this thing by 45 degrees. If you didn't know what you're doing, what's something you might try to do if you wanted to figure this out? I want to learn how to rotate this. I have no clue. What could I try?
I'm honestly clueless.
You're clueless. What do you do when you're clueless?
Google?
Google or the help file, right? That's what I was trying to allude. So if you don't know how to do something, try the help file. That was what that was supposed to be. Sorry if I did a bad job there. Let's go to help. And man, I'm starting to get too many windows here. So I'm just going to kind of clear some of this out. Oh, shoot. I think I just killed the live stream. No, I didn't. Okay, it's still there. Okay, good. Whew. Rotations, it's right there because we want to rotate something. So obviously I don't want to draw an object. I want to rotate an object that's already there. So I go to the rotations and this tells me what I need. I need an angle, an axis, and an origin. I need an angle, an axis, and an origin. Okay. So let's remember that angle, axis, origins. And I just so I've got it here. I need angle, axis, and an origin. Now, the reason I drew that ball, if you're wondering, is because I want to use that ball as the pivot point or that origin. So let me show you what this looks like on the screen. There's the ball. I want to rotate the rod about that point. So I want to use that origin. You can choose. What axis do you want to choose, people? Anything will work. You want to use a
Yes.
Oh, go ahead.
The x-axis? What now?
The x-axis. Actually, if you rotate this rod about the x-axis, what is that going to look like? I'm sorry, I changed my mind. You can't choose the x-axis. If you choose the x-axis, it's going to spin like this, and we won't notice it. It's not that you can't do it, it's that we wouldn't see anything. Do you agree?
Yes.
So let's go back and pick a different axis.
Let's do the Y.
The y-axis? Okay, so what I want to do then is I would like you to rotate this thing about this y-axis, but a y-axis that runs through the ball. Now, I just want to point out that 1 unit in there is basically j hat, right? That's the j hat. How do you write the j hat in Python? How do I write j hat in Python?
It's the middle term, no?
Yeah, so it's 0, 1, 0. That would be rotate about a vertical axis through that ball. So again, we want to use an angle, an axis, and a location. We'll call that the origin. So what do we want to use for this particular case? The angle, I think we said, was 45 degrees, but we have to convert it to radians. The axis is going to be j hat. That's about the vertical axis, which that is going to get converted to vec 0, 1, 0. The origin is I want to rotate this thing about the pivot point. How do I say the pivot point in the code? Do you know? What would be the shortest possible way to specify that pivot point in the code?
Ball.pause.
Yes, that is the key. So any questions about what I'm trying to do here? I've looked in the help file. I found out what it takes to rotate something. And then I'm like, well, these are the things I need. Now that should stay up here. If I go in and edit this program, I better erase the junk that's sitting over there. So I'm going to try and copy this in and see if this makes sense. You type in the object you want to rotate, then you put a dot. Then you tell it rotate. Whoa, whoops, edit undo. Control Z for undo. Sorry about that. Then you tell it to rotate. The angle I want to use in this case is my angle in radians. The axis I want to use is j hat. And then the origin is the location of the pivot point, the ball. So far, so good? When I run it, what do you think it should look like now? You don't have to tell me, but just think to yourself, when I hit run, the line should be rotated. Let's take a look. I'll give you 10 more seconds to think about which way the line should be rotated. It's rotated about the y-axis 45 degrees if the origin was through the ball. For example, we're assuming that the origin is running through the ball, and I can't quite draw it here, but it's like going out where it's going straight up, so I can't really draw it. But it's basically right there. And it rotated 45 degrees. What if I had used negative j hat as my axis? What would be different?
it would be mirror image.
Yep. So here's how you could tell I rotated this right. Take your right hand, take your right thumb, and line it up with the axis that runs through the ball. And notice if you go 45 degrees, you would curl it this way. If you had done negative. So let's see if that's really true. Okay. So let me clear these drawings. If I go into here and say the axis, whoops, let me check the chat here. Okay, Gonzalo, sounds good. Thanks for your time. If I stick in a -1 here, it should rotate it the other way, right? There it did. What if I instead use this vector? What will it look like? I'm rotating it now about the center. That's different. So now I'm using the origin as the axis of rotation. So so far, are we good enough on that? Hopefully that's pretty good. So now, what if we want to animate this? What are the things you need if you're going to make something animated?
A loop.
Okay. What else, if I'm going to use that, what else, what do I usually define right before the loops? You want to do a while loop that runs for a certain amount of time. You need to tell the computer what your start time is. What's a good start time?
0.
Yeah. What else do we usually say? We need a time step. Right? And then while you don't have to do this step, I find it useful so that we immediately specify the rate. So this allows us to slow the animation down or speed it up easily. You don't need that, but it's convenient. So there's that loop. Okay. And let's just go half speed. All right. Now, right now, it's not going to do anything. So we need to tell it to do something. You want to rotate the rod. Now, I want to point out, do you know any equations that relate the rotation to time? Do you know any equations that relate these rotational variables, alpha or omega, to time? Any equations? This might be tricky. I'm going to help out. By definition, how does alpha relate to omega?
Omega over time.
Yeah, the derivative, right? Now, isn't that approximately equal to delta omega over delta time? If I rewrite this another way, isn't that the same thing as saying alpha is equal to omega final minus omega initial over change in time? Are you okay with that? I hope that's okay. If I solve this equation for omega final, what do we get? Kinematics equations. This is what I would like to do. I would like to figure out the latest value of omega, right? Because omega is going to change. If this thing is accelerating, every time in the loop should have a different value of omega. If there's an angular acceleration, omega should change. And this describes how it should change. How would I code that? Do you know? I'll start with this. I want to change omega. What do you think I might type next? If you want to change something, you want to update it. Do you type equals or plus equals?
Plus equals.
I want to plus equals this. And then now that's going to say take the old, what that plus equals does, if you look at it, all of this stuff between the plus and the equals, you don't have to write. If I plus equals it, I say take the old value and what do I want to add to it? This junk. How do I type that junk using code? What should I type next?
Line X alpha times delta
Yeah.
T.
Yeah, and I called it DT. So yep, line X dot alpha star DT. That updates the angular momentum. That changes the angular momentum to its newest value. So far, so good. Next, I want to rotate the line. Now, here's the problem we face. I want to take this into here. I want to copy it and paste it in here and do something with it. Now, I'm getting a lot of annotations here, but sorry, let me clean up a couple of those because I moved some stuff. Let me clean up this junk. The problem is I do not want to rotate this thing by 45 degrees over and over and over again. Right? So I can't keep using this angle in radians. I need a different angle here. Everything else should work. Agreed? This just tells me where's the axis of rotation, where's the pivot point, where's the pivot point, and where is the axis's orientation. So what angle do I need to rotate this through? So I need to think about a relationship between the angle and the omega. Do you know a relationship between angle and omega, anyone? It looks similar to, but not the same as this. Am I losing you here?
Is it angle over time?
Okay, d theta dt. What does d theta dt equal?
Not sure.
Omega. Check the
Okay.
units. Check the units. This is radians per second. Do you see it? Sort of like up here, this one was radians per second or per second squared. So the units can sometimes help you remember this. Now, this is going to be a subtle, sneaky point that might frustrate you. When I'm rotating this thing, all I need is d theta. I don't actually need the value of the angle. I need the value of how much the angle changes. Again, I'm going to say that again. In here, I want d theta. I do not want theta. What I want to do is it's already rotated 45 degrees up here. I need you to tell me how much extra it gets rotated. So in that sense, if I rearrange this to solve for d theta, what is d theta? Don't overthink it. It's omega dt. So far, so good? Let me clear out some space. So I need to type something in the code. I need d theta. What is that equal to? What do I type?
Line x omega times dt.
Yep, that's it. And then what do I type in here for the angle I need to rotate? Is it theta or is it d theta? Sorry, I cut you off there. It's d theta. That was the whole point. When you rotate the line, we don't want to rotate it by the entire angle. We just want to change the angle a little bit. And each time, think about what this is going to do now. You have a value for alpha. You go a small amount of time, that gives you a new value for omega. You use that new value for omega to calculate the tiny amount of angle you move. Then you rotate the rod. Then you repeat this. We'd better be careful, though. What's something we always have to do after we finish all our guts? We got to update the time to the next time step. There it goes. You see it? It looks like it's getting faster. Do you see that? Now, if we run this at real time, you might see it a little bit better. I don't know how well this is showing up. So it's rotating. Let me do a quick check and see if I'm killing you guys or not. I have no idea. Is this helping or not?
I'm enjoying it. It's very helpful.
Okay, let's get back into there. And I had no idea how long this would take, so I apologize if it's taking longer than we expected. I had no clue. All right, so now, what else did I want to do? There's a couple of tricks. One thing, let me do this. You may not be used to this, but I'm going to do a new move that you haven't seen before. I'm just going to write it in here. This is not required, but what I'm going to do here is this says, don't start the loop until you click the mouse. This is going to be useful. Watch now. I can run this thing. I can line up the rotation right. And now when I'm ready, I hit click and I could see the whole rotation. That's a useful feature. So you can put a message on the screen that tells people click the mouse to start the loop. But again, that's all I did there is scene dot wait for parens click. That's how you tell the computer to wait for a mouse click. Pretty handy. And now I'm going to show you why. Here's our rod. We know this thing is going to start rotating. We know it's going to rotate this way. What I would like to do is think about this end of the rod, and I want to draw the velocity vector arrow for that point. And this is the part of the lab that's tough for people. So I want to go through that with you, and I think if we could do that, we'll call it good. So just tell me right now, which way should the velocity arrow point?
Upwards to the left.
This way at 45 degrees. Do you agree?
Yes.
So we know where this thing should point. So before we try to animate it, let's just see if we can figure this out. This is omega. What is the relationship between V and omega that you know? How does V relate to omega?
The distance?
Yeah, V equals R omega. But when we're coding it, this is going to be a little bit tricky. We need a vector. So how do these vectors relate? Is this true? Is that true? Is it that simple? By me asking it that way, you probably guessed that it's not. So here's the problem. That is the R vector, right? From the pivot point to this final location. So that is what I'm trying to figure out here. But R is actually a vector. Now, if you recall, if I could just look at this one, we know that omega in this case, keep in mind that the yellow, right now we're looking at this coordinate system. Remember that J hat is out of the page, even though it doesn't look like it because I rotated the screen. J hat is out of the page. That's supposed to be a J hat. So in this problem, we know that omega is equal to some number in the J hat. But the velocity does not point the same direction as omega. Do you agree with that? The velocity arrow does not point out of the page, but the omega vector does. Huh. Do you know any ways to multiply two vectors? I have two vectors here. What are our options for multiplying vectors? There were two ways in chapter 3 we discussed to multiply vectors. Do you remember that?
Tip to tail?
That was adding, multiplying. What were the two types of products we could use?
Dot.
Dot and cross. Which one do you think applies?
Cross.
The cross, because I need a vector. So the cross product works. So the question is, which way should I write it? Is it omega cross R or R cross omega? If we could just try it and see which one looks right, we'll get it. So I'm going to pause. Do you have any questions before I erase my drawings on the left side of the screen? I'm going to erase the drawings on the left side. Is that okay? Going for it. So that's what we're trying to do here. We know we need this arrow to point up and to the left, right? So let's go into our code. Whoops, I missed one. Sorry about that. Okay. And so in this case, let's just start with this simple one. I need an arrow, right? Let's give it a name. How about V arrow? It equals an arrow. Where should it be located? Where should I put it? If you recall, this is tough stuff, isn't it? So remember we had the ball sitting here like this. That's our pivot point. And then we had the rod. I'm going to draw it in black here at a 45-degree angle. And I'm interested in drawing the arrow at this point, right? That's where I want to draw it. When I say arrow dot position, is that talking about the tip of the arrow or the tail of the arrow?
Tail.
Tail. So this is the arrow's position. I'm going to cheat and just call it v.pos, but I mean v arrow.pos. Okay. I'll just say arrow. Okay, there we go. Next. Okay, so how can I get that position with the stuff that I've already written in the code? What should I type? Go ahead.
Is it linex.axis?
Yes, but I have to first put it at the ball's position and then add that to it. Does that make sense? Because the axis is not necessarily at 0. If you recall, our origin of our coordinate system is sitting over here somewhere, right? The origin of the coordinate system was like this. So if I just did the axis, that would go over to here. Does that make sense? Because it would start at 0. I need to start at the ball's position and then add the axis. Talitha, is that okay?
Yeah, I get it.
Yep. All right, cool. So, all right. So now, before we go on, what's something I could do to check my work before going on?
Run the program.
Yeah, sweet. The arrow's in the right spot. Good job. Now we need to get the right size for it. Well, it seems to me it would make sense to define the R vector. That goes from the pivot to the arrow's position, essentially, right? Or to the end. So how could you describe that? I want to get the R vector. What should I type in now? This is the R vector. This is R final. This is R initial, or whatever. What would I type in?
Isn't it 0.05? No, that's not right.
Let me show you what I would type. That will handle any situation. You might be right for one specific case because you're trying to do the math, but this makes the computer do the math for me. It says go from the final position. It's final minus initial. That will go from where the arrow is tail's located to the ball. That gives me the R vector. Dana, does that make sense?
Yes.
And then let's do this. That needs to be a cross product. And we want to do R with omega, let's say. But we're going to run into trouble here. Omega, the computer doesn't know what omega is. What should I type here? I can't just type omega. What do I have to type to get the...
Dot vec.
We're going to have to do... Yeah, so let me put it this way. We could also define a vector. And that should be a vector. And now, what was the axis we chose in this problem? Was it the y-axis? I think it was. That creates a vector that we could use. We're using the same exact omega, but we're putting it into vector form so we can use the cross product correctly. So we'd actually type line x dot omega vector. Are there other ways to do this? Perhaps. Omega underscore vector. That should get this done. I'm going to pause there. Did that make any sense?
Yeah.
Let's run it. Is that going the right way?
No.
No. So what do I need to do to flip it?
Put a negative.
I could put a negative sign, or I could just flip the order of the cross product, because that's equivalent. And that is the hardest part in tomorrow's lab. Now you know the hardest part. The issue is making this thing, getting the vectors and the scalars worked out so you can draw the arrows properly. Got it? That is the hardest part. And now we could probably stop. Now, if you want to go deeper into this, you could, what you have to do tomorrow in lab is draw the acceleration vectors. So there's going to be a tangential and there's going to be a centripetal. And so you're going to have to think through some of these issues, and we could talk more about that tomorrow. Now, I do have a question for you here. If we go into here, if you want to animate this, what would you do? If you want the arrow to be updated, what do you have to do? In the loop. As the rod rotates, which of this crap is going to change? Do I need to draw a new arrow every time, or do I just need to change the position and axis and stuff of the existing one?
Position axis.
So what are the lines of code required to change the position and axis, if you had to guess? Which line numbers?
Just 23.
All
Okay.
three, because you not only need to change the location, you need to change its axis, right? So let me run this program and show you what will happen here. If I get this thing set up and I zoom out a little bit, there it is to start. If I click this, the issue is it rotates, but things don't update. So what I need to do is I need to go into here. If I just copy this crap, this is the stuff that changes the location of it. Now I got to put some tabs and make sure I didn't screw up the indents. But when I look at this one, what are we doing here? I rotate the line's axis. That's going to change this value. That's going to change the arrow's position. That's going to change the R vector, and that's going to change this. So when you run it now, you see it changing? Maybe I should change this a little bit. Let's start with 0, and let's make this 2. And when I run it, hopefully it's more dramatic. It's all right. We don't see any arrow. Should start growing sometime. Oh, did I comment something out? I don't know, but all right. Now I feel like I'm wasting your time now. Now we're just dinking around a little bit. Somehow I screwed something up. Oh, shoot. I might have referenced something. Oh, you know what else we have to do? We have to stick this line of code in there too. Because what we forgot here is that we were updating omega in the code. We also have to update the omega vector in the code. So now when I run this, hopefully it'll work. Sorry about that. Is it going? Come on. There it goes. You see it? It starts working. And I'll say one more thing. Now you could start to play around with this. You could give this a negative initial rotation rate and run it. and we see it shrink because out. And so this is one of the reasons you have to deal with the vectors, because what about plus and minus signs, right? All right. Now I'm stopping that live stream.